So today we're going to talk about nutrition. Nutrition seems to be a very boring and dry topic, but nutrition is important to your patients in all aspects of care. In long-term care settings, acute care settings, anything like that is going to be important for nurses to educate their patients about nutrition as far as what is beneficial to them and what can be harmful for them based on the disease processes that they have occurring at that moment. It will be a continual thing because patients are not always the most compliant and they don't always understand. So sometimes you can't just tell them things, you have to give them examples, give them handouts, and you have to re-educate them on a regular basis, especially as the disease process itself changes for them. So that you've got to remember that it's an ongoing thing for these patients. So nutrition itself encompasses all the processes involved in consuming and utilizing food for energy, maintenance, and growth. So just think of that: nutrition, energy, maintenance, growth. The physiology of nutrition then involves first ingestion, which is simply the taking of food into the digestive tract, generally through the mouth. In special circumstances, though, ingestion occurs directly via the stomach, via feeding tube. And we'll talk about feeding tubes at a much later time. Digestion itself, then, it refers to the mechanical and chemical processes that convert nutrients into a physically absorbable state. Mechanical digestion involves mastication, which is simply chewing, which breaks those food into fine particles and mixes it with the enzymes in the saliva, and then deglutination, which is simply swallowing. Peristaltic waves and mucus secretions then move the food down the esophagus. So think about that. Ingestion, simply taking the food into the mouth. The mechanical part of digestion, which is mastication, chewing, and mixing all that food with saliva and enzymes. And then deglutination, the swallowing of that food, and the movement of it by peristalsis through the esophagus. Chemical digestion is in the process where enzymes, gastric and intestinal juices, bile, and pancreatic juices change that food into individual nutrients that can be used by the body. So this food has to go through a whole chemical process before it is usable for the body. Digestion begins in the stomach, except in those certain cases where starches, where digestion begins in the mouth. But in almost all situations, digestion begins in the stomach. It's completed in the intestines. Peristalsis is that rhythmic, coordinated contraction of the muscles in the GI tract, and that forces that chime through the small and large intestines. Only carbohydrates, proteins, and fats require chemical digestion to make nutrients available for absorption. Absorption then is that process where those nutrients, that end product of digestion, pass through the epithelial membranes in the small and large intestines and into the blood or lymph systems. So absorption is how those individual nutrients pass through the intestines and into the blood or lymph system. They're typically absorbed and taken to the parts of the body that need them because they're water soluble and go directly into the villi, and into the bloodstream. Fats are not water soluble, so they are absorbed first into the lymph system and then eventually make it to the circulatory system. So everything else water soluble directly from the intestines into the bloodstream. Fats not water soluble, so they must go through the lymph system and then to the the circulatory system, into the blood. Metabolism then is that conversion of nutrients into energy. This is the sum total of all the biological and chemical processes as they relate to nutrients. Metabolism involves two processes: anabolism, which is a constructive process of metabolism, and it's where those new molecules are synthesized and new tissues are formed, such as in growth and repair. Catabolism is that destructive process of metabolism, and it's where tissues or substances are broken down into their component parts. This is the process that releases energy. So catabolism, destruction, energy released. Anabolism, constructive, and it's where new tissues are formed. During metabolism, energy is also produced by the process of oxidation. This simply means that there are chemical processes of combining nutrients with oxygen. This energy that's produced is used in a number of ways. Electrical energy from oxidation is for brain and nerve activities. Chemical energy is for the metabolism. Mechanical energy is for muscle contraction, and thermal energy is simply to keep the body warm. You do not have to know those specific processes of oxidation, but just be aware of them. The metabolic rate is the rate of energy utilization in the body. It's expressed in calories. 1 calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. Okay, so 1 calorie is the amount of heat required to raise the temperature by 1 gram of water by 1 degree Celsius. So the most important thing of that is to know what the metabolic rate is, the rate of energy utilization. Because of the large quantity of energy released during metabolism, the energy is expressed in kilocalories. 1 kilocalorie is equal to 1,000 calories. The major factor that affects basal metabolism in the body, I skipped what basal metabolism is. Basal metabolism is the amount of energy needed then to maintain physiological functions when a person is at rest. It's the lowest level of energy expenditure. So basal metabolism, at rest, lowest level of energy expenditure. The major factor that affects basal metabolism is body composition. Lean muscle has a much higher metabolic rate and produces much more energy than does fatty tissue. Generally, women have a lower metabolic rate than men because they have less lean muscle mass. They have a much higher percentage of fat tissue. Now, there is a distinct difference here though. During menstruation, pregnancy, and lactation, metabolism increases for women. So men, much more lean muscle mass than women, so they almost always have a higher metabolic rate. Age is also a factor because it has an influence over growth periods, and growth periods then increase metabolism as well. Glands in the body affect metabolism, especially the thyroid gland. The rate of metabolism is governed primarily by the hormones of the thyroid, which are T3 and T4. Hypothyroidism decreases the secretion of thyroid hormones and causes a lower metabolic rate. Hyperthyroidism then has an increase in the secretion of thyroid hormones and has a much higher rate of metabolism. So just remember that. Body structure, age, glandular activity, especially the thyroid. Excretion. Excretion is simply that process of eliminating and removing waste from the body. The biggest issue in excretion is dietary fiber. Fiber and other indigestible materials such as salts and other products like bile and water are formed into feces and excreted from the body as solid waste. There are other organs that aid in the digestive system as well. And one of the obvious should be kidneys, because they eliminate the urine, the, the bladder, the sweat glands, the skin, and the lungs. Most of the liquid waste is sent through the kidneys and bladder to be excreted as urine, and then some is removed from the sweat glands as perspiration, and then gaseous waste are eliminated through the lungs. You should be able to remember that from when we talked about IVs and we talked about intake and output, and that your intake is equal to your output, and it's based on those things: the kidneys, the skin, the lungs. So now let's talk about specific nutrients. There are 6 types of nutrients that function efficiently and effectively: water, carbohydrates, fats, proteins, vitamins, and minerals. If a person eats a well-balanced diet, then all of those nutrients are provided by the food that they take in. Nutrients are classified as energy nutrients, organic nutrients, and inorganic. So those energy nutrients that you have on page 366, table 18-2, those energy nutrients are those fats, proteins, and carbohydrates. The organic ones then are carbs, fats, proteins, and vitamins. Inorganic, water, and minerals. Energy nutrients, which are those carbs, fats, and proteins, release energy for use by the body. Organic nutrients build and maintain body tissues and regulate body processes. So those are those carbs, fats, proteins, and vitamins. Inorganic provide a medium for the body's chemical reactions, transport materials, maintain body temperature, promote bone function, and conduct nerve impulses. Those inorganics, water, and minerals. And you will need to know those classifications and which nutrients belong into which classification. All of their functions for nutrients are interrelated. So the next thing that we're going to talk about is water. Water is the most important nutrient. It's more vital to life than food. Almost every body function requires water. People can live for weeks without their food, but approximately for only 10 days without some form of water intake. Water is the main constituent in every cell of the body. We talked about that also when we talked about extracellular and intracellular fluids. Approximately 55 to 65% of the adult's weight is in water. I think when we talked about IV fluids, I told you 60. And then for an infant, about 80% is body. Of the body is water. Water content decreases with age. So your daily requirements for water. It's based on several environmental factors, such as temperature and humidity, and then physical factors such as activity level, metabolic need, functional losses, age, respiratory rate, and the state of health. Higher environmental temperatures and vigorous physical activity cause more water loss, and then more must be replaced then. Generally, 1,000 mils of water is needed to process every 1,000 kilocalories eaten. That's a lot. So the state of relative water balance exists when the body has adequate fluid distribution appropriately as intracellular and extracellular fluid. Again, remember that intake and that output should be approximately equal. Excessive intakes of fluids is not a problem for healthy individuals. More in simply causes more out.